do this lesson, the modeling clay, quote unquote, you'll see why I put that in quotes, needs to be pliable and be able to be formed into a variety of different shapes. The clay provided by the wonderful District of Worthington seems to have dried out or like rubberized or like it doesn't really like form. I know. So we're gonna have to do some sort of like reviving to save this clay, but it doesn't. It's like non-functioning in what we want to do. So yeah, and a bunch of you guys are on the science trip today, right? Raise your hand to go on the science trip. Yeah. So that is worth a bunch to me because that's like a quarter of the class. So maybe someday, probably after testing, we'll get to play with clay and make geometric shapes. But right now, we're going to do an exercise in imagination. Because the clay isn't working. No, don't worry, I will provide you more candy as the year goes, but not right at this moment.
The year's almost gone. It smells like medicine in the hospital right here.
I have shots.
Yeah, it does.
Alright. Alright. So, imagination, experiment, lab, whatever you want to say. Imagine that we made a rectangular prism, right? Like a cube. And now you could make a cube or a rectangular prism. No. So, straightforward honesty. I talked myself out of grading your guys' math journals because I needed a break, both physically and mentally. I came in twice over break, and couldn't do it. I had to meet with summer school people to give them paperwork, so I wasn't here very long, but I tried to start grading stuff, and I could not do it. It was a mental funk or whatever. Yeah, I have them, but not to give you that. No, so I'm going to try to get that done tonight, now that I'm back in like school mode, and kind of getting the brain back into it, because we got a 7-week sprint to the finish. But no, I don't need a math journal. So that's why that just says math book toolkit, clean paper, because no math journals. So if you had a rectangular prism or a cube, and you wanted to cut it, and you took a string or whatever, and you cut down through it. Now, the first thing that you think is probably like every time you see somebody cut a cake or anything else like that, so we're just going to cut top to bottom straight. But I have a challenge for you. So hold up. Rectangular prism, you cut straight down through it. At the cut, what sort of shape would you make? A rectangle, right? Or a square. If you had a cube, it could be a square. So my question is, how could you cut and make a triangle? Or how could you cut and make a trapezoid? Or any of the other shapes on that list? So I want you guys to discuss with your team what of these shapes could be made by cutting a prism, like a rectangular based prism, and how. If it can't be made, just justify why. So take a few minutes. How could you get this? Yeah. It's like one straight cut through. But, so, let me clarify what we're actually talking about. We are talking about cross sections, which I guess I can show this. If I took this clay and I look at it as a cylinder, right? It's round, it's flat on the top and the bottom, it's a cylinder, and I cut it, like I lay it like this and I cut it, the cross section is the region in which your cut touches. So I like to talk about it like, so if I have a lightsaber and I cut across you like this, the cross section is round, right? The cross section would be like your belt. Now, if I had a lightsaber and I cut you like this, it would not be. It would be a really awkward shape, right? Like round and then kind of in at the neck, and then like flat edges on the back and kind of a round edge here. And it'd be a really weird shape. So think about it as like lightsaber, whatever you want to think. But if I cut this, it'd be a circle, right? But hold up, I don't have many eyes up here, and I don't know why. Hey, what are we doing? if I stand this like this and cut it vertically, what sort of shape? Oh, who said rectangle? A rectangle. Right? Because think about this. Say it.
The cut line is like a rectangle. You're not looking at the whole entire 3D shape. You're looking at the cut line.
You're only looking at the 2D cut line that goes through. So, if we cut kind of awkwardly through there, or if we cut diagonally through it, or horizontally or vertically, each shaped by its own unique cut. So we know that rectangle is easy. We know that square could happen if you had a cube or anything like that. How could we make a triangle, or a trapezoid, or a parallelogram, or a pentagon, or any of those? Chat about it. So you guys talk about it on the bus.
It really stinks because I wanted to do that, but I didn't get on the bus. I was on the wait list, but I never got it.
There's no joke.
Yeah, I know. There's this science.
They're doing an energy project thing at one of the elementaries.
They're teaching energy to fifth graders. Fifth graders? Yeah. Whoa.
All right, so to get your brains thinking, and just because we lost like half the class, how could you cut and make a triangle at the as the cross section? So what do you mean by diagonal? So we have a cube, a prism, or whatever. Diagonal means a lot of different things, right? If I cut diagonally like this, and I go through this edge and through this, I still get a rectangle. Right? It's at a weird angle when I cut it. How could where my lightsaber hits make a triangle, Oliver?
So here,
Yes, yeah.
So what I thought you could do is you didn't even have to cut the whole cube. What I thought you could do
It just
is
jumped out of my hand.
you could cut here and cut to the middle, because then that would leave a flat edge here and you'd get a triangle.
So, if you can visualize what Oliver's saying, essentially connect these corners, these three, make that your cut. So it comes across from this corner to corner, that's the bottom of your triangle, down through there, and you have bottom of the triangle, edge, point at the tip of the triangle. So we could make a triangle, but you got to cut a corner off, essentially. Now, you wouldn't even have to cut the entire thing, because I can do that anywhere. Imagine if I might as well Sharpie on this. Actually, this will be easier to present to you. So imagine, this will pop up in just a second. I do, I just got more this morning. So imagine you want to cut the corner off this cube, right? Cube. So you slice across here, and then down this side, and down that side, right? Cut the corner off. When you do that, this that you just cut would pop off, and that would actually be a triangular pyramid. Because this, yeah, and the face where you just cut off, whether you look at the bottom of the triangular pyramid you just made, or what's left from the cube, would just be this triangle that you can kind of see. Can you see the triangle?
Yeah.
Top of the triangle, bottom of the triangle, and then these are your two edges. So is there a way to make a trapezoid? We gotta remember what trapezoid is, right? Parallel bases, yeah, angled sides one way or the other. Like, doesn't matter, it could be flat with one angled, it could be both angled in, it could be both angled out. So think about it like a trap. Have you ever seen an animal trap? It's flat top and bottom, and then it's got like angled doors or something weird going on to catch the animal. That's why it's called a trapezoid. Can you make a trapezoid? Yeah, so two sets of parallel sides, right? So, wait, wouldn't a square or a rectangle be a parallelogram?
Yes.
So we already done that, actually, right? Like, so we've checked that box. Pentagon. Could I get a five-sided shape? Is there a way to cut one line through a prism cube?
Straight line.
What do you mean straight line?
Because you could cut weird like that. Just cut.
It's got to be a straight cut. Yeah, straight cuts.
Well,
So what we were gonna do in the lab is have like a string or floss or whatever, and you were gonna cut down through it. But apparently it doesn't work very well either. I want to invent my own way, but it's probably gonna use something like hot.
you need
easiest
like a
way.
wire.
Butter, hot wire, or any wire really. But butter would be
Wire
perfect for this
itself.
lab.
Like there's this tool in our class where it's basically string, but you have like things on the ends so that
It's made-
Yeah, so you can hold it.
Yeah, so you can hold
Yeah.
it and it helps you to cut through it. But you kind of hold those and then wrap the string around your like fingers so that you have like double grip, and then you kind of stretch it and then cut through it.
Yeah.
But it doesn't really make a straight cut actually. It kind of like makes it ribbon.
Could we make like a hexagon or a pentagon or an octagon?
Make a shape that has more sides than the ring shape.
Wait, so think that out. What are you saying?
I'm trying to picture in my head different ways to cut it, and I can't figure out a way to make a shape that has more, a face that has more sides than the, sides than the original shape's face. What I'm thinking, but I don't know.
Well, we just made a three-sided,
That has
right? We
less,
made a triangle. It has less.
not more.
So, what if I tell you we can make a pentagon?
I believe it.
We can make a hexagon, but we cannot make an octagon. And obviously, circle would be beyond kind of what we could do because
Unless you
it's
just
round.
Well, with straight, I was gonna say with straight lines.
But even if you cut like this,
It would still.
it's a flat cut. And the object, if I make a flat line through it, but I want you guys to ponder on that. And we're going to keep talking about cross sections, this whole lesson, cross sections. How could we make a hexagon out of a cube? How could we make a pentagon out of a cube? We made a triangle. We made less sides. How do we make more? So we're going to come back to this. I like to leave questions where you guys are pondering and actually interested. All right. So what's the difference between a prism and a pyramid?
A prism is, well, it depends on what kind of prism, because a prism can be like an triangular, or I forget the other words, but it's just like, it has like a place, and it just like goes out, while a pyramid has like a square bottom, and then has triangles coming up to one point.
Ooh, I like it. Square was a little specific for me. Square bottom. It doesn't have to, actually. But everything else you said I love. Absolutely perfect. Now, it can have a square bottom. You're absolutely correct. It can. It doesn't have to.
Prism has two bases that are the same, and then the sides are the same. And then a pyramid has one base, and then triangle has two sides.
So let's real quick, and my smart board's all screwed up today. So I'm going to try to write some things. But let's define. So prism same bases. Sorry, this is really screwed up. On top and bottom. Hey, Ava. Now I'm actually asking that you guys do like student type things instead of just doing in the textbook. Same bases. What connects the bases with each other?
Same thing.
Other
Great
bases.
job.
Other, no, same
Rectangle,
size,
square.
same stuff.
Four-sided shape. Stuff isn't square.
I love the word stuff.
Okay. Same shape.
All of these. So like pentagon, top and bottom, right?
Rectangle.
Rectangle, top, bottom. Square, top, bottom. What the faces that connect the top and bottom to each other are what shapes? Rectangles. Thank you. So same bases, rectangular faces connecting bases. Sorry, that's awkward. Correct, but it's not necessarily a square. A pyramid, on the contrary, only has one base. It can be almost whatever shape you want. It has to be a polygon, so a multiple-sided shape. So triangle is the smallest base that we could have. You could have, oh, sorry, I forgot the triangular prism also. So that's another prism, right? Pyramids, this is harder because I can't stack. So, triangular pyramid, smallest base that you can have, or like, smallest amount of sides. Square pyramid, so like you normally see the Egyptians that we talked about. Pentagonal pyramid, pentagon on the bottom, still goes up to a point. Ooh, you okay, man?
Do you have a decagonal?
I do not. This is as high as this goes. Hexagonal, right? But all of these faces going up to the top are what? Triangles. Like Alex already said, so we have one base, and then triangular, or you could just say triangle, because it's not triangular, it is a triangle. Triangular faces to a point.
What's the point in that?
Yeah, that was just that. But, yeah.
Our cylinders technically prisms because they're not connected by rectangular faces, but they are.
You tell me. What is cylinder be a prism?
I don't. It has the two bases, but it just doesn't have the rectangular sides because it's a bit rectangular.
I don't know. Leave that as a ponder for right now.
Can you just
What do you
tell
think?
us?
No, it's not fun if I just tell you everything. I want you to be interested. Oliver.
In my opinion, I think a cylinder would be a prism because if you take the net of the cylinder, if you put the two circles out, and then what's connecting them is technically a long rectangle that connects. So it's really one long rectangular face.
I didn't hear a project on this. I should know the answer, but I can't remember.
It's what? It's up. Yeah, you're fine. But so when I look at the net, right, I've got my cylinder, and when I look at the net, I've got the same bases, right, exact same, and the connection of the bases, when I net it, right, lay it all flat, is a rectangle. So that is a question to ponder. Very good question. All right, we got to keep moving on. And my smart board's being goofy. So, rectangular pyramid. Right, now that we know pyramids versus prisms. Rectangular pyramid, if we slice it vertically, what are we going to get? We can talk about this.
I know
get
this
half
one.
of a
Cross section, right? So we're not talking about what 3D thing is left. At the slice. Like what your lightsaber interacts with. What shape will end up burned, whatever. Crispy from the lightsaber. Oliver?
No, I was thinking of what shape would be left, not what shape is the cut.
Okay. Alex?
Well, from what I was thinking, like if you were to cut straight down, it would be like, for the cut space, it would be like a rectangle. But
Ooh, straight down, straight across.
straight down, but if you were to cut straight across, it would be the same shape as your base.
Ooh, now we're getting really crafty. If we cut vertically, now this is what I didn't say. Vertically where? If it's vertically in the middle, we'll get what kind of shape? triangle, right? Because I go through the top, down the side, down this side, across the bottom. But if I bump my cut, actually I can't write on these with dry erase, which is convenient. Check this out. So I'm going to bump my cut over, right? Instead of cutting through the tip, I'm going to cut like right through here. You guys all right with that? Then come down, and then the cut would connect across the bottom. What kind of shape is that? I got a flat top, edges, flat bottom.
Well, if you cut it so that we can see the whole thing.
So there's your front, right? Sides, bottom.
No, it'd be a trapezoid.
Be a trapezoid.
That's what I was saying.
Yeah,
I'm waiting for lots of people to get there on their own. Right, so check this out. And if I can angle this and make it an even weirder trapezoid. Sorry, this is where most of you guys are, so I'm just standing back here. I could cut through the shape, even like this, and still flat at the top, flat at the bottom, two angled sides, we get a trapezoid. The only way to get a triangle is if I cut through the tip and go down. Right, so any other cut, if it's vertical, make it, or diagonal, it'd still make a trapezoid. If I cut through here. Well, so now let's start talking horizontal, right? If I just cut a horizontal, Alex told me it's going to be the same shape as my bottom, but what would be different about it? I agree, it will be the same shape as the bottom.
It will be smaller. Oh.
It's always going to be smaller, right? So I cut halfway up the pyramid, it'll be half of the size of the bottom. If I cut a quarter of the way up the pyramid, be careful.
It'll be 3/4.
It would be 3/4 of the base shape.
9/10 would be.
And then if you just like cut off the bottom, then no.
Yeah. If I just
Like,
cut
as close
off
as
the
possible.
bottom.
You can't get it exactly because you can't.
It's like when you're slicing cheese, but your slicer keeps coming out of the cheese, like you're just as close
And
as
then
possible.
it gets like a shit, and you're like, I just want a straight slice of cheese.
So
And
we
you use a knife.
hold on. So we figured out triangle. If we cut through the tip, we figured out rectangle or squares if we cut through the middle. We figured out trapezoid. Are there any others? Is there anything else we haven't talked about? Lana, what do you think? You seem to be working on something back there. I'm curious what you got going on. You can make a really weird long rectangle. Now we can never go like outside of it. We got triangle, square, rectangle, trapezoid. Parallelogram is kind of like redundant. We can make a pentagon. We can make a pentagon. We need 5, right? Pentagon, 5 edges. Do I have 5 faces that I could cut through, Ava?
No, but I might know how to do it.
You might know how to do it. Get some pure white behind it. What are you thinking?
At the bottom you can cut triangles.
So I can only do 1 cut.
Oh.
You're kind of making.
I have no idea.
Is it possible to cut through every face, including the base?
So I got 1, 2, 3, 4, 5, right? So if, like Piper just said, I think about what if I cut through the base of it. Okay, let's say we'll cut, I don't know, like here. Sure. Then 2, 3, 4. My angle's probably off, by the way. 5. 1. Sorry that my focus is bad. 2, 3, 4, and 5. Sorry, I keep wiping it off accidentally. So we are only limited for what shapes we make, or can make, by the number of faces my 3D object has. Because look at this. This, if the angle was a little bit better, would be the high point of the cut. And this would be the highest point because my lowest point is going to be directly opposite it down here. So I'd start cutting through both of these faces, then both of these faces as it comes down. Then you don't want to reach the corner. You want to get to somewhere in the middle so that then it has to go across the bottom. Does that make sense? At least a little bit. Because we have 5 faces available to use here. Yeah, it's still a straight line. It's really hard to show this. That's why the clay was going to be useful. Alana, what's up?
My question was, if you make like multiple cuts.
No, so we're talking about single cuts.
Okay.
Right now, like that's the rules we're working with right now.
Oh no, shapes.
Oh no, shapes. You guys already know how to do probably all of this slide.
Yeah, probably.
So the volume of the prisms is lagging.
Lag is dead.
So did you guys ever work with I forget the little cube dudes that like the unit cubes and different things
Yeah.
that I have some back in the closet. I just don't know if I feel like getting them out. Or they'd give you like a little square, and then they'd give you a stick of like 10, and then they'd give you like a panel of like 100.
And then a block of 1,000.
Yeah, and then a block
And
of
you
10
could-
by 10 by 10.
And they had like little indents so you could build things.
Yeah. So essentially, and this is really basic. I was surprised that we didn't like combine this lesson with anything else. The only reason I didn't combine it with anything else is half like a bunch of your class left. We know that cubes and prisms and all these things can be broken down into littler pieces, right? Like little 1 by 1 by 1 cubes. And hopefully we understand the difference between area being flat space and volume being the amount of space inside of something. The difference between how much carpet got wet and how much water got spilled. Right? Like area of carpet, volume of water. So, if we have a 6 by 8 by 9, that really means how many cubes do we have going across the bottom? 6. How many cubes deep? 9. How many cubes tall? 8. So each layer is 6 by 9. Right? The bottom is a 6 by 9, the next is a 6 by 9, the next is a 6 by 9. So if you visualize those cubes in your head, the volume makes sense. It's easy with prisms. It's not with pretty much anything else. So do not think that I'm telling you this is easy. But prism volume, we should be able to think about it as the little cubes. Think back to those. I wish I could remember the name of them. But yeah, does that make sense to us? Think about it as broken down by little cubes. And you guys have probably already seen that volume is length times width times height. I know some of you know this because you've tried to use that already this year. So let's just to practice a little bit, go ahead and jot out on your paper V equals L times W times H. I like to use kind of like a cursive L because then you can obviously tell it's not a 1. That's like a me thing. And then we want to fill in length, width, and height. 6, 9, 8. Does order matter when I plug those into multiply? No. And I could turn my shape, right? The height could easily become the length. So 3D, right? There's no up or down really.
432.
432. Now we don't have labels on the numbers given to us. What do we label it? Units cubed. Because then, when you figure out what the units are, you just plug it right in. In your head, what's the volume of the little prism there? Alex?
24 units cubed.
24 units cubed. Make sense? Those are easy. Right, prisms are easy. Be careful as we venture into other shapes. So, still a prism, right? But now, sorry, I'm getting confused with which problem is which. I'm going to skip this actually. Let me check my book for a second to see how much I want to skip. Yeah, we're done. we're gonna need to review this stuff with your classmates. So you guys might as well just work on homework the last 10 minutes. This is the last question of the lesson, anyways. This is just starting to get into composite shapes. So when one prism can be combined with another prism, or if that's the only thing we see, we don't quite know how tall things are or whatever else. But yeah, we're good. Go ahead and start working. Let me know if you guys have any questions.